Okay, so let's look at some of these true-false statements from Calc Chapter 2, number 1. So we got this graph here, and we're trying to figure out whether or not these limit statements are actually correct or not. So in the first one, it says the limit as x goes to -1 from the right side. That's that little plus. So as x gets close to -1, but from the right side of -1, so over here, right, as I get closer and closer and closer to -1 for x, the question is, what do the y values get close to? And, sorry, let's erase that. And it turns out that the y values get really close to 1 right there. So, and it doesn't actually matter what happens right there, it's just the y values are close to 1 around there. So this is true. This one's true here. Okay. And number 2, it says the limit as x goes to 2 of f of x doesn't exist. Well, let's look at the limit as x goes to 2 from the left side. And the limit as x goes to 2 from the right side. So from the left side, as x gets close to 2, the y values are really close to 1. Right? Again, it doesn't matter what happens at 2, just to the left of 2. And just to the right of 2, the y values are also close to 1. And when they're the same, then you can condense it to say limit as x goes to 2 without any plus or minus there, and say that that equals the same value. So in this case, it does exist. It equals 1. So this statement is false. The second statement is also false because we just showed that the limit as x goes to 2 of f of x is 1. So this one's also false. In the next line, let's see, as x goes to 1 from the left, so as x goes to 1 from the left side, so here's x equals 1 and we're approaching it from the left side, the y values get really close to 2 here. So this is true. And as I get close to 1 from the right side, right here, the y values are also close to 1. So this is also true. Let's see, the next one says limit as x goes to 1 of f of x does not exist. Well, if we looked at the left-hand side and the right-hand side of 1, we got 2 and we got 1. Those aren't the same. Since they're not the same, then you would say the limit does not exist. So this is true too. Let's see, the next one says limit as x goes to 0 from the right equals limit as x goes to 0 from the left. So 0 from the right and 0 from the left, they both approach the same value, happens to be 0 as well. So this one's also true. The next two are a little bit more confusing. This says, for every c in this interval between -1 and 1, if I plug that in here, then the limit exists. So that's this region right here, everything between -1 and 1, right? So if I pick any point between -1 and 1, not including those, so like this point, does the limit from this side equal the limit from that side? So then you could say that the general limit exists. And it turns out, yeah, whatever point I pick along here, doesn't matter which point I pick, if I look at it from the left side or the right side, the limit exists, and it happens to be the value of the function right there. So this one is true too. Oh. Sure. Okay, and then the last one here says for everything between 1 and 3. So that would be this part of the picture that looks like this. So here's 1, here's 2, here's 3. Everything in this region here, does that have a limit for any value that I pick? So if I pick this value, yeah, sure, the limit from the left and the limit from the right are going to be the same. If I pick this value, same deal. Limit from the left, limit from the right are the same. So the limit exists. The one place where that gets messed up is right around 2. Well, at 2, if I look at the limit from this side, from the left, that's still the same as the limit from the, still the same as the limit here from the right side. right? That's still going to have the same y value of 1 here. So even at 2, the limit exists, and the value is 1. So this one, no matter what point I pick in this interval here, I can still approach it from the left and the right and get the same value every time. So this is also true. So really, there are only two false ones here, B and C.